Hi everyone. Thanks for being here. Welcome to our newest webinar, The Future of Sorting, live from inside an AI-powered MRF. Oops, there we go. Before we get started, I wanted to just go over a few housekeeping items. First, this webinar is being recorded, and I am going to send out a copy of the recording to everyone that was registered in the upcoming few days. And then second, we will be doing some Q&A at the end of the presentation. So if you have any questions that pop up during the webinar, feel free to place them in that Q&A chat at the bottom of your screen. Really quickly, wanted to introduce you to who will be speaking today. Hi, my name's McKenna. I'm a marketing manager here at Everest Labs. I'm going to be talking you through some slides, giving you an overview of what we do, and then I'll be moderating a little bit throughout as well. And then we have Valeria. Valeria is a senior robotics engineer, and she is going to be giving you the tour through the MRF. I want to start with a brief overview of Everest Labs. We're the developer of RecycleOS, which is an AI and robotics solution for recycling facilities and the recycling value chain. Like this slide says, our goal is to empower recycling facilities to maximize recovery, reduce waste, and ensure no recyclable is left behind. So how do we do that? RecycleOS is made up of vision, AI, robotics, and data. And this slide is kind of depicting how that all works together, which you will see in real time today. So to start off, we have a vision system, which you can see in this first video that is deployed over a belt, and it identifies everything that runs under it, everything that it sees, as you can see in the second video. And we do two things with that information. The first is we tell the robot what material to pick and where that material is on a belt. And the second is we collect all of the info, all the materials that are identified, and we place that into customizable dashboards for our customers to use so that they can monitor and optimize their operations. And the other thing that's not on this slide is that we remotely monitor all of our RecycleOS systems through our robotic operations center. This monitoring is 24/7, and if we see any issues with like the robot, the line itself, or we see anything hazardous on the line, we can immediately notify our MRF operators. All right, so what are we going to see today? Today we're at Alameda County Industries in San Leandro, California, which we will be referring to as ACI throughout the tour. So if you hear that, that's where we're at. The ACI MRF was originally built in 2000, and it's has a capacity to process around 15 to 20 tons per hour of both residential and commercial materials. Like many MRFs across the country, ACI has faced persistent labor challenges over the years, like absenteeism, injuries, and just constant stress of having enough people to run their facility safely and efficiently. It was really a recurring pain point that impacted their productivity. So in 2021, they decided to partner with Everest Labs to tackle these challenges. And ACI started with 4 Everest Labs robots in 2021. And after seeing strong performance, they added another one in 2023. And they just added one more last month, which we're excited to show you. So in total, that's 6 Everest Labs RecycleOS systems operating. 5 work on quality control lines. These 5 are UBC QC, which is used beverage cans or aluminum cans QC, PET QC line, PP5 QC, HTP color QC, and a fiber QC. And then the other robot works on their MTL line, which is a material transfer line. So after these past 4 years, these systems have delivered some really impressive results. ACI has saved over 1 million in labor costs, and by using our robot as a service model, they have achieved payback of about 3 months. So with that quick overview, we're going to get into what you guys really wanted to see today, and I'm going to have Valeria start sharing her screen. And then I will stop sharing and Valeria can get started. All right, over to you.
Hello, everybody. Can you hear me fine?
Let's try it. Can you get a little closer? It's a
Okay, how
little,
is that? Hello?
yeah, yeah.
Awesome. Thank you, McKenna. Hi, everybody. My name is Valeria Avila. I'm on site here at the ACI plant. I'm a robotics engineer with Everest Lab since 2020. And so I've been able to see the entire development of the product, which makes me very excited to share with you today. This is my bread and butter. This is what I do every day. So super stoked to be here. So we're going to start with aluminum seed line, as McKenna mentioned. We're picking up anything that is not an aluminum can. So your Pepsi, your Coke, and we're picking up contaminants on this line. So tin cans, aluminum foil, trash, paper, you name it. We see all of that in this line. It being so slow, we're able to recover as much as we can. And so I'm going to walk you through the different parts of our system. So this line presents a unique challenge because it's at an angle. So you can see here our vision system. It's mounted at an angle as the material is coming in. And then you can see the conveyor line goes to a flat. So as Georgia shows you right here, the robot is dropping the objects into three different chutes. You can see there's a chute right there already that was existing. And there's a space between the chute and the arm where we were able to squish two different trash cans and increase the amount of classes we can separate. So with that, we're able to separate the tin cans, the aluminum foil, and the trash. So if you follow me over here, you can see the underarm tooling is modular. What that means is that I can attach anything I want. In this one, I added a level compensator where I'm able to add extra compression and make sure that my attempts are successful. We currently are able to guarantee you 85% of our attempts to be successful just because you know the environment, but that's actually really good. We're able to monitor it. And if we see any drops, we will let you know. So if you follow me this way, I'll show you how we can enhance or make sure that our attempts are successful. So I programmed this robot so that it can come to a maintenance position. Once it's safe, the interlock can unlock and I can access. And so every robot has their maintenance kit with a bottle brush. What I ask of my customers is to brush it once a shift. So make sure that there's no clogs. And right now it's kind of wet. It's raining. The material is wet. You can get clogs pretty easily. So as long as you do that once a shift, you can make sure that this robot is working properly. So I'm going to put it back in production. Now, the only thing that I also ask my customers to look at is that the suction cup is not torn. So let's look at the other arm. Like I said, the underarm tooling is modular. So we can use different attachments to it. Here we have the suction cup that is normal. This is a normal size. And I want my customers to be able to replace it easily. So we designed an attachment that is just plug and play, no threading required. You can easily replace it like that, and you're back in business. Now you can see this line. This is the PTQC. So I am picking up all those contaminants. So let's put the robot back in business to reduce the downtime here. So the sorters and the operators are able to come in and change the cans as they need. So as you can see here, this was a very compact space. That's one of the advantages that we can go into very small footprints. All we ask is that customers can install our platforms where the robots are. That's a space of where a person was right here. So we didn't ask the customer to increase the space at all, which is a huge advantage. So what I'm going to do up there so you guys can see better the robots that we have downstairs. So follow me. The other advantage we have with our arms is that we can install unreachable areas. So if you can see up there, we have this conveyor belt that is at an angle up in the air. No sorter was there before. So we were able to ask ACI to install a platform for us so that the robot can be up there. It's at an angle, it's fast, that's a material transfer line. So that's a perfect job for a robot. Now we're gonna go up here so you can see better. So I'm going to show you the system here. I remember installing this robot back in, I'm going to say 2021. The area is very compact. We only had, I want to say 4 feet between when the vision installs it to the end of the line. So that's one of the advantages we have also because our system is so compact, we can go in very small spaces. So you can see this is an HDPE QC line. We have those chutes in front of the robot, so we can just drop them. Another advantage of using our robots, they're very dexterous. So if I want to drop into odd places, the robot can do that easily. I can maximize the amounts of picks per minute that I can reach because I can just go up and down to pick and drop. The vision system, the arm, and other 4 ways of separation. So that is a huge plus. This arm has done on average 56 picks per minute. The arms can do up to 60. So with your help, we can make sure that they are maximized. I'm going to show you another one. These two arms are PTQC and PP5QC. They're dropping into the belt in between them that is at an angle. That is pretty impressive to me because it's kind of unreachable for normal arms or other configurations. We got a sorter on each of these positions. So these arms are able to take that place. You can see the material transfer line better up here as well. I'm picking Tetra Pak, fiber, and HDPE as well. The customer was able to build those chutes for us as well. So let's come down and see the fiber line that we have. And like always, we have our safety cages that we program them to make sure that the workers around us are safe and they're able to maintain them with no problem. Now, if you guys have any questions, you're welcome to drop them into the Q&A as McKenna is going to be monitoring that. Now, we work with different widths of conveyor belts. The narrowest being 2 feet, which is what you saw just now. 3 feet, which is what a person can normally reach, up to like 5 to 6 feet. Normally, those belts that are wider tend to be fiber lines. So we're walking into the fiber line area. Now, right now, we're having some pretty serious weather going on. So some of the material is wet right now. But I want to show you the new configuration we have on the fiber line. So because we want to increment, we want to maximize the reach the robot can use. Normally, when we install the robot on the standard platform, we're able to reach 3 feet. But because this is a 5 feet wide belt, I want to maximize that. So we have just developed this new way of mounting the arm above it. We can take advantage of the 6 feet total of reach. And yeah, so because of dexterity as well, I can program it to be maintained in different positions. So this is one of them. And easily I can just brush it once. Again, check the suction cup is healthy, no torns. And then put it back. All I ask from my customers when we're going to install one of these is that they give us an airline for compressed air. I ask them to give us internet, and I ask them to give us internet, airline, and power. Put it back on. Normally, I like to train the model based on what's on the line. I install the vision. We collect the data for a week, 2 weeks. And once we're able to train the model, we can tell the robot what we want to pick based on what's on the line. And that way we can make sure that the robot is picking well. So with that, this is how we're going to end the tour. So I'm going to send it back to you, McKenna. Thank you for watching.
Great, thanks. I'm going to go ahead and reshare my screen. As Valeria said, we've been having some pretty crazy weather out here in California. So the material has been interesting at the plant, which has had us on our toes. But really quickly, I wanted to cover a very important part of our solution that we weren't able to talk about as much on the tour. So that is our Vision AI. When we put a vision system over a recycling line, as I talked about previously, and as you saw, we can identify every material that runs under it, and we can collect this data and put it into customizable dashboards, as you can see over here. What can you do with this data? So with continuous material composition recycling stream analytics, we are able to track, audit, and optimize plant performance, help you proactively fine-tune sorting equipment and conveyor lines. We can spot and reduce contamination or sorting issues to deliver cleaner, higher value bales, and track what materials are recovered, missed, or sent to landfill to optimize recovery and revenue. And with this information, our customers have been able to make a lot of data-backed profitable changes to their operations. And I really wanted to focus over on this section right now. These are a bunch of our customer case studies that are specific to our Vision AI, but this one over here is interesting. So this customer put our vision system on their last chance line. And for those of you who don't know, last chance line is the last chance or it's like the last line before materials are sent out to landfill. And ideally, this line would just be made up of trash and not valuable recyclables, but that's just not the case at this point. So what this customer wanted to do is put the vision system on to understand what types and quantities of valuable materials were being sent to landfill from their facility. So they were looking at materials like aluminum, HDPE color, HDPE natural, and PET. And after having our vision system on this last chance line, our data showed that they were losing about $54,000 monthly in these recyclables that they could be recovering. So what did they do with this information? They made some equipment and staffing changes to help them improve the recovery of the material upstream. And specifically, they adjusted their eddy current separator and optical sorter settings. They also placed a manual sorter on the aluminum line after the optical sorter. And after all of those changes, their losses went down to only about 16,000 every month, and that is a savings about 38,000 monthly. And this is just having our vision system on there. There's no robotics on this line. If you wanted to put robots on there, it could help recover that additional $16,000 that was being sent to landfill. So there's a lot of potential opportunity with just using Vision AI. And if any of this sounds interesting to you or your operations, I just wanted to plug that we do provide free no risk site surveys. So if you offer or if you operate a recycling facility and you're interested in seeing where AI and robotics might work best for your operations, you can reach out to us and we can go ahead and set something up.